great scholars, great mathematicians. Let us deal with division of whole numbers today. Division of whole numbers today, and we shall be considering one of the methods today and some things you need to know about numbers that are to be divided. Division of whole numbers. Sometimes if you divide two whole numbers, you might end up having your answer to be another whole number, or your answer to be a decimal number, or your answer to be a fractional number. So you'll be learning this in the course of trying to deal with this topic, division of whole numbers, today. Quickly, if you have 15 divided by 3, 15 divided by 3, in our mathematical language, 15 divided by 3 is written as 15 over 3. I can as well rewrite this expression in a different form as starting from 3. 3 divides 15, and this is written as 3 with a vertical line, 15. That is what it means. This is 3 divides 15. You write it in this form, and 15 divided by 3 in this form. They both explain or saying the same thing. 15 will always be the up number, and 3 will always be the down number. The up number is called the dividend. So 15 is the dividend. 15 is called the dividend. And 3 is called the divisor. 3 is called the divisor. The answer we are going to get when we do that is called the quotient. The answer we will get is called the quotient. 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 And if there's any remainder, then you write it somewhere. Now, quickly, let us deal with this method for today using a direct method, not the long division method, a direct method of trying to understand the digits that are in the dividend. Let's use 15 now, for example. 15 divided by 3, that will be expressed as 15 over 3. You're actually asking yourself, how many 3 are in 15? How many 3s are in 15? So if you know your 3 times tables, you can say your 3 times table and look and stop at the number that will multiply 3 to get 15. That number, of course, will be 5. 3 times 1 is 1, times 2 is 6, times 3 is 9, times 4 is 12, and times 5 is 15. So 15 divided by 3 is 5. But you can actually use your counting of sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. You have 1, 2, 3, 4, 5. So your answer is 5. So 15 divided by 3 is 5. I said you can as well use the direct method by simply asking yourself how many 3 are in 15. But to do that better, always consider the first digit. Always consider the first digit in the dividend. Can 3 go in 1? Can 3 go in 1? 1 is the first digit in the dividend. Can 3 go in 1? The answer is no. Then look at the two numbers, 3 in 15, you get that 5. Let's see another example. You have 1, 5, 6. 1, 5, 6 divided by 3. This time, the dividend is a 3-digit number. The dividend is a 3-digit number. We have 1, 2, 3. To be divided by 3, so I will do this. 1, 5, 6 divided by 3. I'll ask myself, if you want to count sticks, 156 sticks to help you find out the number of trees we have in 156, you keep on counting sticks and you'll be tired. So the way to go about this is this method. How many 3 are in 1? Always consider the first digit number. The first digit number. How many 3 are in 1? 3 cannot go in 1, so look at 15 as the first number, 15. How many 3 are in 15? We've dealt with such problem here. Our answer is 5. Write the 5. So I said first, consider 1. If it does not work, consider 2 digits, which is 15, and your answer is 5. Write it there. You're left with 6. How many 3 are in 6? Your answer is 2. So if you divide 156 by 3, you will get your answer to be 52. Let us look at another example. 245 divided by 3. 245 divided by 3. You have 245 divided by 3. Let's see what we can do here. 3 in 2. Always consider the first digit. The first digit. If it did not work, then look at the 2 digits, the first 2 digits. If it did not work, look at the first 3 digits. But now let's look at the first 2 digits. How many 3 are in 2 is not possible. Then look at 24. How many 3 are in 24? Your answer is 8. If you want to count your 24 sticks, you can do that and get your right answer. But the answer is 8 because 3 times 8 is 24. So write your answer here. 8. Write your answer there. Then you're left with, you've already dealt with 2 and 4. You've dealt with this one. So you're left with 5 now. And there's no remainder. If there was a remainder, I would have written the remainder close to this number to have a new number. But since 3 goes into 24 perfectly 8 times, there's no remainder. I'm done with that. Then how many 3 are in 5? How many 3 are in 5? Your answer is 1. Remainder 2. Put the remainder 2 up here. There's no number left for me to attach that 2 to it. That is why I choose to write it up. If there was a number left here, I would have written this 2 before the number. But since there's no number left, let my remainder be up. So my answer is 81. Now you can put your answer properly. You said 3 in 245 is 81. Remainder 2. That's what you said. Remainder 2. That is the answer you said. 81. Remainder 2. You can rewrite this answer properly now in fractional form. Remember I said sometimes your answer may be whole number like we have here. Sometimes your answer may be fractional or decimal. Now you said your answer is 81, remainder 2. So you come up, down, and write 81, remainder 2. That remainder 2, that number that is left is your numerator. So write it up 2. All over the same denominator, all over 3. This is our answer in fractional form. But if we are asked to put your answer in decimal form, this is how it works. You write your 81. Since you said your answer is remainder 2, you now ask yourself, can 3 go in that 2? Can 3 go in 2? The answer is no. Put your point. Put a point here. After your answer, put a point here. Then add 0 to that 2. That becomes 20. How many 3 are in 20? Your answer is 6, which is 18. Write a 6. Remainder 2. Because 3 times 6 is 18. Take it out from 20, you have remainder 2. Can 3 go in 2? The answer is no. Do not put another point at the front of 6 or add another point here. That is not mathematics. You already add 1 point here, which you use for 20 here. Don't add another point. If 3 cannot go in these 2, just add 0. Keep on dividing. 3 in 20 is 6. Remainder 2 again. 3 cannot go, add 0. 3 in 20, 6. Remainder 2. 3 cannot go, add 0. That will be 6. Remainder 2. You keep on having remainder 2. And you keep on having 6, 6, 6, 6 in that form. This type of number, this is called repeated decimal. When you see a number of this form that has, after the decimal point, you have similar numbers occurring in that manner, then such a number is called repeated decimal. Such a number is called repeated decimal. Now, that number that produces a result that gave you repeated decimal is called a rational number. Rational number. Rational number. A number that has the property of exhibiting repeated decimal. That number is called a rational number. So I can rightly tell you that 245 divided by 3 is a rational number. Why? Because it produces a repeated decimal. 0.666. You keep on having 6 in that manner. If I ask to keep on dividing, you keep on having 6. But I'll not go further. I'll stop my answer here. If you're asked in your examination, keep your answer in one decimal place, then stop your answer at this 6. If they say 2, stop your answer here. So, but this is called the repeated decimal, and a number that can give you such result is called rational number. So 245 divided by 3 is a rational number. Today we have dealt with simple division. I've mentioned to you the dividends, the divisor, the quotient, and we have solved some problems regarding division. In our next class, we're going to deal with other problems still on division, but we'll try to use different methods in solving problems of such. Thank you.